Okay, in Unit 1, Lesson 1, we're going to be looking mainly at comparing rational numbers. If you think about rational numbers, they can be expressed in several different forms. They can be expressed as fractions, as decimals, or as percents. We have to be able to compare them no matter what form they're in. The hardest form to compare is always going to be fractions. So I have to remember that in order to compare fractions, we have to write them so that they have the same denominator. And here's a good example. If I ask you to add 3 cars plus 4 trucks. Well, you know that 3 plus 4 is 7, but what are you going to call it? There's no such thing as a car truck. But you could come up with a word that names cars that also names trucks. For example, vehicles. So you could say 3 cars plus 4 trucks is 7 vehicles. So you're just finding a common name. Same thing with fractions. You find a common denominator. In 5th and 6th grade, you practice finding the least common denominator. That's always what you want to try to do just because it will make your calculations easier. Let's look at a real quick example of that. Let's say we have the fraction 3/4 and 2/5. So fourths and fifths, that's kind of like cars and trucks, so we can't compare them in that form. We have to rename them. So when we're talking about a common denominator, we're looking at multiples. So if I take the number 4 and think, well, if I count by 4s, I'm going to say 4, 8, 12, 16, 20. If I count by 5s, I'm going to say 5, 10, 15, 20, and there you go. There's the first number that appears in both lists. So my common denominator would be 20. But then I have to think about the top number. 3/4 isn't the same thing as 3/20. So I think, well, what did I do to get that 20? Well, 4 times 5 is 20. So I have to do 3 times 5. And say, okay, well, 3/4 would be 15/20. And then I would say, well, 5 times 4 is 20. So we do 2 times 4, that's 8. So 2/5 becomes 8/20. Now I can compare them. 15/20 is greater than 8/20. Because they have the same denominator. So let's look at that. So it says, which fraction is greater, 3/4 or 4/5? So if I'm looking at 3/4 and 4/5, here's your denominator, always the number on the bottom. We've got fourths and fifths. So you want to think of the least common denominator is 20. In other words, the smallest number that's a multiple of 4 that is also a multiple of 5 is 20. So, well, we do 4 times 5 to get 20. So we do 3 times 5, and that's 15. So 3/4 equals 15/20. Then we say, well, 5 times 4 gave us 20. So we've got to do 4 times 4, and that's 16. So 4/5 is 16/20. Well, 15/20 is less than 16/20, or we can say it the other way around. We can say 16/20 is greater than 15/20. Therefore, we can say 4/5 is greater than 3/4. Now, method 2, I'm going to show you this method. I don't recommend it just because it involves you having to be able to break your number line up into equal pieces just by hand, and sometimes that's kind of hard to do, especially if you have some tricky denominators. So if we want to compare those same two fractions, 4/5 and 3/4, then let's say this is 0 and this is 1. So to get 4/5, I've got to break this into 5 equal pieces. So let's maybe say 1, 2, 3. So I've got it broken into 5 equal pieces. So that would be 1/5, 2/5, 3/5, 4/5. Now to show fourths, okay, so halfway be about right there. So that's a half, or 2/4. So then 1/4 be about right there, maybe. And then you would have 3/4, maybe about right there. And so from the number line, we can see that 4/5 is greater than 3/4. Now, again, I don't recommend doing that way because you have to eyeball equal intervals on the number line. That's not necessarily easy to do. And you sure don't want to try to draw a number line and break it evenly into 20 pieces. And so that's one way to look at it so you can visually see the comparison, but I wouldn't suggest that you solve comparing fraction problems that way. Okay, so look at some more examples. So we got 1/2 and 3/8. Well, in my mind, that one's easy to compare because 3 is less than half of 8. And so you can think, well, half of 8 is 4, so it would take 4/8 to get exactly to 1/2. So automatically I know that 1/2 is greater, get a different color. I know that 1/2 is greater than 3/8 because to get half of 8, I have to have 4. So I know that 1/2 is equal to 4/8. So 1/2 must be greater than 3/8. You could do it the same way. You could find a common denominator. You could say, well, 2 and 8 both go into 8. So I could say, well, 2 times 4 is 8. So I'll do 1 times 4, which is 1. And we left this 8, so we can leave the 3. And obviously, whoops, I said 1 times 4 is 4. I didn't make that a 4. There you go. And 4/8 is greater than 3/8. Okay, because 1/2 and 4/8 are the same thing. Look at this next one, 1/2 and 5/9. Well, since one of my fractions is 1/2, I would use the same logic that we just talked about. 5 is more than half of 9, because 5 is half of 10. So I already know that 1/2 is less than 5/9. Now, if you wanted to go ahead and check that with a common denominator, I know that 2 and 9 both go into 18. So I can say, well, 2 times 9 is 18, and 1 times 9 is 9. And I can say 9 times 2 is 18, and 5 times 2 is 10. Now that 9/18 is less than 10/18, so that means 1/2 is less than 5/9. Negatives. Getting into negatives is a little bit tricky. So 7ths and 11ths, and 5 is more than half of 7, 6 is more than half of 11, so I really can't use comparing to a half. So I'm going to go ahead and use a common denominator. So 7 and 11 both go into 77. So 7 times 11 is 77, so I'll do 5 times 11, which is 55, so it's negative 55/77. 11 times 7 is 77. 6 times 7 is 42, so I have negative 42/77. Now, right away, you look at that and you think, okay, negative 55/77 is bigger because 55 is more than 42, but this is negatives. So you think negative 55/77 is going to be farther to the left. It's going to be closer to negative 1 than negative 42/77. So negative 55/77 is actually less than. If they're both negative, you have to think backwards, okay? 55 is greater than 42. Negative 55 is less than negative 42. So we would say that negative 5/7 is less than negative 6/11. The next one, 4 and 9/10 and 4 and 3/5. And really just ignore the whole number. They both have 4 wholes, so we can ignore that. 10 and 5 both go into 10. We didn't change the 10, so we don't change the 9. And I can say 5 times 2 is 10. 3 times 2 is 6. So 3/5 and 6/10 are the same thing. Well, 9/10 is greater than 6/10. So 4 and 9/10 is greater than 4 and 3/5. Okay, now let's look at ordering numbers. Now we've got fractions, decimals, and percents. Anytime you have all 3 forms of the number, you always want to write everything as a decimal because decimal numbers are the easiest thing to compare. So I know that 70%, okay, percent means out of 100. So 70% means 70 hundredths, which we write like that. Tenths, hundredths, so there's 70 hundredths. The next one's already written as a decimal. It's 0.6. I can still put a 0 after it, same thing. 2/3. Okay, to write 2/3 as a decimal, you have to dig back in your brain to what you learned in 6th grade. Top number in the house, bottom out, and we divide. And 3 goes into 26 times. Drop a 0. Okay, that's gonna repeat. So here we get 0.6 repeating. That's what that bar means. We'll be talking more about that later. So that means there'll be another 6 here. So from least to greatest, well, the smallest thing we have is 0.6. So there's our smallest. And then the next smallest thing would be this 0.6 repeating, which came from 2/3. And that leaves us with that 0.70, which came from 70%. So there they are in order from least to greatest. Okay, next one, same thing. We've got numbers written in all different forms, so we want to get them all in their decimal form. So we have 8/10. Okay, 7/20. Let's show a little trick on 7/20, just because it has a nice friendly bottom number. Orange is not showing it very well. Okay, if you think about decimal values, you've got tenths, hundredths. I think, oh, well, 7/20. 20 goes into 100. I could say 20 times 5 is 100. So 7 times 5 is 35. So 7/20 and 35 hundredths, those are the same thing. And I can write 35 hundredths like that. You could have done top in, bottom out, and gotten the same thing. And then 17% is the same thing as 17 hundredths. I can put a 0 there. And now let's write them in order from least to greatest. Well, that's clearly the small one, or smallest one. So we'll say 17% is the smallest thing up there. This would be next, and that came from 7/20. And this is the biggest one, and that came from 8/10. So there they are in order from least to greatest. Now, obviously this was the greatest one. 7/20, that's less than half. It takes 10 to be half of 20. And we know that in percents, 50% is half, and 17% is way less than 50%. So we could probably have reasoned that 17% was the smallest number up there. Okay, so we'll go same thing here. The first two are already written as decimals for us, so that makes that nice. And then 2 and 7/50. Well, I know it's going to be 2 point something. And what I would think to myself for 7/50, since 50 is a nice pretty denominator, is I would say, well, 50, if I double 50, I get 100. So that means I would double 7 and get 14. So that's 2 and 14 hundredths, like that. And we can fill these holes in with zeros. And now the smallest thing we have is this one. So 2.105 is the smallest number in that set. And then the next smallest one would be this one, which came from 2 and 7/50, which means the greatest number we have up there is that one, which came from 2 and 15 hundredths. So there they are in order from least to greatest. So that's it for comparing numbers in fraction, decimal, percent form. You should be ready now to begin working on practice 1-1. If there are any questions on that practice assignment, if you'll circle those, put a star beside them, and have those ready to ask when you come to see me in Math Workshop. Have a great day.